It began, as many engineering mysteries do, with a wreck. A twisted, smoking heap of aluminum, steel, and scorched paint lay crumpled in the corner of a muddy French field in the autumn of 1943. The aircraft had been brought down only hours earlier after a brutal dogfight near the German border, and while its pilot had escaped by parachute, the airframe remained more or less intact, at least enough for the recovery crews to drag it back across the lines under the cover of fog and darkness. The aircraft was a P-47 Thunderbolt. To the German recovery specialists who had spent years dissecting Allied machines, from Mustangs to Spitfires to B-24s, the P-47 was something different. Something monstrous. Something deeply American in a way that no one in Germany fully understood yet. It wasn't sleek. It wasn't elegant. It wasn't nimble. It was a brute force assault of raw engineering, bizarre priorities, and overwhelming industrial confidence. They called it the flying beer barrel. The Americans, with their sense of humor, called it the jug. But to the German engineers who would soon pry apart its enormous radial engine, the P-47 would become a symbol of something far more terrifying than any single fighter plane. It would become the doorway through which they would glimpse the industrial avalanche waiting behind it. What they would discover buried in the heart of its powerplant would shake even the most confident Luftwaffe analysts. Because when German engineers opened that engine, piece by piece, bolt by bolt, cylinder by cylinder, they discovered it wasn't simply a machine. It was a promise backed by 15,000 more. The wreck arrived at a test facility outside Rechlin, the Luftwaffe's premier research and evaluation center. It was still streaked with mud, its wings dented, the fuselage peppered with holes from anti-aircraft fire and the rough landing. Mechanics shook their heads at the sheer bulk of it. Even stripped of ammunition and most of its fuel, it weighed more than some fully loaded German bombers. But the real prize was in its nose. The Pratt Whitney R-2800 double wasp. 18 cylinders arranged in two massive rows, each one its own miniature combustion chamber capable of producing stunning amounts of power. German engineers had heard rumors about this engine months earlier. It powered not only the P-47 but also the F-6F Hellcat and the F-4U Corsair, machines that were starting to make unwelcome appearances in battlefield reports. The Germans had long relied on inline engines, sleek, liquid-cooled, and aerodynamic. They admired the engineering elegance of the Daimler-Benz DB605 and the Junkers Jumo series. They produced remarkable horsepower in compact frames. But the Americans had taken the opposite approach. They built engines the way they built their cars and factories, big, loud, and immensely durable. The R-2800 was the epitome of this philosophy. Some Luftwaffe pilots joked that a P-47 didn't fly, it bludgeoned its way through the sky. And now the German engineers were about to take one apart. The first thing they noticed was the sheer scale of the components. Each cylinder head looked as though it belonged on a small tractor. The cooling fins were thicker and heavier than comparable parts on German radials. The crankcase was built like a vault, overengineered to withstand immense stresses. The supercharger, mounted behind the engine and nearly the size of a small car's engine, was a labyrinth of ducting, gears, turbines, and compressors. One engineer, Hauptingenieur Walter Riedel, muttered as he ran a gloved hand across the manifold. "So this is what a country looks like when it's not running out of metal." Another engineer laughed. A few others didn't. They all knew the truth. Germany was already under severe resource strain by 1943. Aluminum was harder to come by. Skilled machinists were increasingly redirected to emergency repairs. Factories worked under constant threat of Allied bombing. But the R-2800, it looked as though it had been built with complete indifference to material cost. Even the bolts were oversized. Riedel held up one of them and shook his head. "This is overkill, ridiculous, wasteful." Then he paused. "But it will survive anything." That was the first shock. The P-47's engine was not built to the same philosophy as German engines. German engines were precise instruments, finely tuned machines that required care, attention, and often frequent overhauls. The American engine was something else entirely. It wasn't designed to be perfect. It was designed to keep working even when everything went wrong. Oil leaks, no problem. Bullet holes, patch them and fly. Overheating, push it harder. Battle damage, absorb it. Abuse it. Run it at power settings no German pilot would dare maintain. And it worked. This was an engine built for war. Not a theoretical, polished, engineering competition war, but a dirty, brutal, get the job done no matter what, war. But the second shock was about to hit them even harder. As they dismantled the supercharger system, they found the heart of the mystery, the turbo-supercharger assembly tucked deep inside the fuselage. The Germans knew turbochargers. They had experimented with them before the war, had built prototypes, and even fitted a few high-altitude aircraft with them. But nothing they had ever created looked remotely like this. The American turbocharger was a masterpiece of mass-production metallurgy. Its turbine blades were made of alloys Germany simply could not produce at scale. Its ducts were heat-resistant and uniform. Its components fit together with astonishing precision. The entire system allowed the P-47 to maintain full power at altitudes where German fighters were gasping for air. "This is not hand-built," one of the engineers observed. "That is impossible," Riedel replied. "Something this complex must be." But it wasn't. This was the third shock. The Americans had industrialized complex supercharging to a degree Germany had never imagined possible. The P-47 wasn't just a fighter. It was the tip of a spear forged in dozens of factories, using processes that had taken years to perfect. The Germans studied every weld, every casting mark, every stamped code, every serial number. The serial numbers are what broke them. Each major component of the P-47 engine, supercharger housings, compressor wheels, crankcases, cylinder barrels, carried tiny, neatly stamped numerical sequences. These were production numbers, and they weren't low. One part they examined had a serial number in the tens of thousands. Another was in the 30s. A third, an innocuous-looking turbine housing, carried a number above 14,000. Riedel froze when he saw it. "This cannot be correct." The others gathered around. "If the sequential numbering is accurate," a junior engineer suggested quietly, "then this one unit is the 15,000th or so to come off its production line." Riedel felt the weight of those words settle over him. 15,000 turbochargers. 15,000 of the most advanced supercharging systems in the world. 15,000 engines of the same type. Germany hadn't built 15,000 of anything so complex in the entire war. And the Americans were just getting started. A report was prepared for the Luftwaffe High Command, and a copy eventually reached the desk of General Galland himself. It was technical, meticulous, and brutally honest. The Americans, it concluded, had achieved something Germany could not match no matter how brilliant its engineers were. The United States had applied assembly line mass production to cutting-edge engine technology. They had weaponized manufacturing. The P-47 the Germans had pulled from that muddy French field was not an anomaly. It was not a rare machine. It was not the result of special treatment or elite craftsmanship. It was standard. In the words of the report, "The enemy possesses, as of this writing, tens of thousands of engines of this class, with the capacity to replace losses faster than they can be inflicted. Each engine is of equal quality." Galland later remarked to his adjutants, only half joking, "Perhaps the Americans will win the war simply by drowning us in engines." He wasn't far off. What the engineers didn't know, yet, was that the Americans were not only producing engines in the tens of thousands, they were producing aircraft in the thousands each month. P-47s rolled off factory lines like cars. Replacement parts were shipped by the crate. Army ordnance teams could rebuild a wrecked Thunderbolt within days if enough parts were available. The German Luftwaffe was fighting a war of scarcity. The Americans were fighting a war of abundance. When German engineers opened the P-47 engine, they discovered that its power wasn't in its horsepower rating. It wasn't in its metallurgy. It wasn't in its size or strength. Its true power lay in the fact that it existed as one of many. The R-2800 wasn't a masterpiece because it was overbuilt, though it was. It wasn't a masterpiece because it could take damage, though it could. It wasn't a masterpiece because it could push the P-47 to astounding altitudes, though it did. It was a masterpiece because the Americans could build them endlessly. For every Thunderbolt shot down, there were 5 more waiting to take its place. For every engine that failed, there were 10 more already crated and shipped across the Atlantic. For every pilot who needed a new machine, the factories of Pratt Whitney and Republic Aviation answered instantly. The Germans had never faced anything like this before. And this was the final, devastating realization. They never would be able to match it. Meanwhile, across the ocean, in a plant in Connecticut, engines identical to the one lying in pieces at Rechlin were sliding off assembly lines. Workers, many of them women, tightened bolts using torque wrenches calibrated not by engineers on the front line but by standardized factory procedures. Crankcases poured from automated foundries. Turbine blades came from forges running day and night. It was an industrial symphony. A supply chain spanning hundreds of companies, thousands of subcontractors, and millions of man-hours. From copper mines in Montana to steel mills in Pennsylvania, from rubber plantations in Liberia to aluminum refiners in Tennessee, a continent's worth of industry fed into the creation of each engine. The German engineers did not know it at the time, but the R-2800 line alone consumed more raw materials each month than some entire German aircraft plants. Where Germany struggled to build one aircraft at a time, the Americans built them in batches. Where Germany tailored engines to specific aircraft, the Americans standardized them across multiple platforms. Where Germany worried about resources, the Americans ordered more. Galland once said, "The American fighter pilot is not the problem. The American factory worker is." It was not an insult. It was a confession. For weeks the German engineers continued their analysis. They drew diagrams. They measured tolerances. They calculated metallurgy compositions. They prepared proposals, some for redesigning German turbocharging systems, others for attempting to replicate certain American features. But in the end, the truth remained. Germany lacked the industrial foundation to produce such an engine in such numbers. Their factories could match individual aspects of American technology. German scientists were brilliant, their engineers world-class. They could build prototypes that rivaled anything in the world. But they could not build 15,000 of them. And in the age of industrial warfare, quantity had become a new form of quality. One evening, as the team was finishing its measurements, the youngest engineer, barely 22, lingered behind. He ran a hand across the massive engine block, still warm from the day's testing. "Sir," he asked softly, "do you think we can ever build something like this?" Riedel looked at the engine, at the complexity, at the ruggedness, at the industrial fingerprints of an economy so large that even its scrap capacity dwarfed Germany's production. "No," he said honestly. "Not because we lack the skill, but because we lack the time, the materials, the factories. The Americans have built an industry we cannot surpass." He paused. "And this engine, this one engine, tells us that." The young engineer nodded, unsure whether to feel fear or admiration. Months later, after the war's tides shifted further and American air power swarmed across Europe, the Luftwaffe found itself increasingly battered by waves of P-47s. They came in groups of dozens, then scores, then hundreds. Thunderbolts bombing bridges, Thunderbolts strafing convoys, Thunderbolts escorting bombers, Thunderbolts diving from high altitudes where their turbochargers kept power strong while the Luftwaffe fighters sputtered. The wrecks that once surprised the German engineers soon became common. But by then, it no longer mattered. The Americans were building more. Always more. Endlessly more. After the war, Allied technical intelligence teams recovered some of the reports written at Rechlin. Buried in the pages of engineering jargon was a sentence that captured the essence of what Germany had discovered. The P-47 is not a fighter aircraft in the traditional sense. It is the flying embodiment of the manufacturing might of the United States. That might was not measured in top speed or turning radius. It was measured in serial numbers. And the Germans had seen enough of them, thousands of them, to know exactly what it meant. When they opened that engine and saw the production sequences climbing into the tens of thousands, they realized something no pilot in the sky could see. For every American aircraft shot down, 15,000 more were already on the way. That was the moment they understood. The P-47 was not a machine. It was the shadow of an army of factories. It was the roar of an industrial giant awakening. It was the beginning of a war Germany could no longer hope to win. And the engine lying in pieces before them, the one they had studied, measured, dissected, was simply the messenger delivering the news. The air war continued. The Thunderbolt became legendary in both theaters, smashing ground targets in Europe and dueling Japanese fighters in the Pacific. Its pilots loved it for the same reasons the German engineers feared it. It was tough. It was reliable. It refused to die. And every time one rolled onto a runway somewhere in England or France or the Philippines, the pilot knew, whether consciously or not, that he was sitting inside the product of a nation whose factories were firing at full power. The Germans had exceptional pilots. The Americans had exceptional logistics. In the end, logistics won. Years later, long after the war, American engine historians visited archives in Europe and found fragments of those German reports. They were astonished by how deeply the Germans had respected the R-2800, not for its elegance but for its embodiment of industrial power. One historian wrote, "The engine that frightened the German engineers was not the one on their table. It was the 15,000 others they knew they could never stop." And so the story of the disassembled P-47 engine became something of a legend, a quiet acknowledgement among engineers and historians alike that war is not only fought with soldiers and machines. It is fought with factories, with foundries, with assembly lines, with serial numbers that stretch into infinity. When the German engineers opened that engine, they expected to learn about American engineering. Instead, they learned about American industry. They expected to understand the P-47. Instead, they understood they were losing the war. What they saw inside that engine was not just metal, or combustion, or pistons. What they saw was the future. And they knew, in that moment, that Germany could not build a future fast enough to compete. 15,000 engines, 15,000 warnings, 15,000 reasons the war would unfold as it eventually did. The P-47 flew because of the R-2800. But the Allies won because of the people, and the factories, who built it again and again and again. In the end, when the German engineers opened that engine, they found far more than machinery inside. They found inevitability.